Io appears to be the primary source of matter that pervades the Jovian magnetosphere, the region of space that surrounds the planet influenced by the planet's strong magnetic field. Sulfur, oxygen, and sodium, apparently erupted by Io's volcanoes and sputtered off the surface by the impact of high-energy particles, were detected at the outer edge of the magnetosphere of Jupiter. The two Voyager space probes made a number of important discoveries about Jupiter, its satellites, its radiation belts, and its never-before-seen planetary rings. The gravitational assist trajectories at Jupiter were successfully carried out by both Voyagers, and the two spacecraft went on to visit Saturn and its system of moons and rings. Voyager 1 encountered Saturn in November 1980, with the closest approach on November 12, 1980, when the space probe came within 77,000 miles of Saturn's cloud tops. The space probe's cameras detected complex structures in the rings of Saturn, and its remote sensing instruments studied the atmospheres of Saturn and its giant moon Titan. Voyager 1 found that about 7% of the volume of Saturn's upper atmosphere is helium, compared with 11% of Jupiter's atmosphere, while almost all the rest is hydrogen. Since Saturn's internal helium abundance was expected to be the same as Jupiter's and the Sun's, the lower abundance of helium in the upper atmosphere may imply that the heavier helium may be slowly sinking through Saturn's hydrogen. That might explain the excess heat that Saturn radiates over energy it receives from the Sun. Winds blow at high speeds on Saturn. Near the equator, the Voyagers measured winds about 1,100 miles per hour. The wind blows mostly in an easterly direction. The Voyagers found aurora-like emissions at mid-latitudes in the atmosphere, and auroras at polar latitudes. The mid-latitude auroras, which occur only in sunlit regions, remain a puzzle, since bombardment by electrons and ions, known to cause auroras on Earth, occurs primarily at high latitudes.